Hello, and thanks for clicking on this next Prenarculus production. Today we are going to talk about composite functions and their domains. Okay, so we're going to take one function and basically place it inside of another. That's what a composite function is, and that's what it's all about. And then we're also going to talk about how to calculate their domain. All right, so let's get started and see what we can do. Okay, so composite functions, the process of composing functions consists of putting one function inside the other. So we have a notation for this. Okay, this is read f of g of x. So f of g of x. Okay, um, and then there's a second notation where you write f of g of x this way. So the notation that you see here on the right-hand side is the one that's most convenient when you're actually going to algebraically figure out what f of g of x is or the composite function is. But you can also see the notation on the left, all right? So if we see g of f of x, it means we're going to take f of x and put it inside of g. You can also take functions and compose them with themselves. So f of x is literally taking f of x and putting it inside its own function. And then same thing with g of x. Okay? All right, so let's get started and let's see how we're going to do this. We're going to start numerically and then we'll work our way down to algebraically doing it. Okay, so I want to know what the value of f of h of 4 is given these three functions. Now, g of x we're not going to need here because we want to know f of h. That doesn't have anything to do with g. So the way this works is you start with the inside function. The inside function is h of 4. So we want to calculate f of h of 4. So the first thing we're going to do is we're going to calculate h of 4. So h of 4, we're just going to put 4 in for x, is half of 4 minus 9. So that's 2 minus 9. That's negative 7. So h of 4 is negative 7. Okay, so now let's come over here. We have h of 4 is negative 7. So now, in place of h of 4, we're going to put negative 7. So now, what do I want to do? I just want to find f of negative 7. So f of x is over here. F of negative 7 is the absolute value of negative 7 plus 2, which is the absolute value of negative 5. The absolute value of negative 5 is 5. So f of h of 4 is 5. And that's the correct answer. Okay? So you're basically doing two problems in one. Two function notation problems in the same problem. All right? Same idea. What's the value of f of g of negative 3? Note you could also see it written like this, f of g of negative 3. But it's much more convenient to work with the notation that you have here and the one on the right. So the first thing we're going to do is look inside the parentheses. That's g of negative 3. Let's calculate g of negative 3. So we're using g of x equals x minus 2. Put negative 3 in there for x. That gives me negative 5. So g of negative 3 is negative 5. So to calculate f of g of negative 3, I now need to calculate, well, g of negative 3 is negative 5. So f of negative 5. Okay, so now we're going to go to f of x and put negative 5 in. So that's 3 times negative 5 squared plus 2 times negative 5 minus 3. Don't forget your parentheses. We have 3 times 25 minus 10 minus 3. 75 minus 10 minus 3. 65 minus 3 is 62. So f of negative 5 is 62, which means f of g of negative 3, or f of g of negative 3, equals 62. And that's my answer. Okay, this is done. All right, that's how we're going to do this numerically. All right, let's try to make it a little more complicated and try to do it algebraically without numeric values. So I want to take these two functions and I want you to find for me g of f of x. Now remember, this also could be written like this, g of f of x, but this way it's easier to recognize. Okay, so first thing we're going to do is we're going to go to the inside function. We're going to start with f of x. Well, there's no number there, but I know what f of x is. F of x is 3x squared plus 2x. So I'm going to take that and put that there in place of f of x. So I'm going to write g of 3x squared plus 2x. Okay, so now I'm going to come over to g. Here's my g of x. It's equal to 4x. And I'm going to replace all the x's with 3x squared plus 2x. So g of 3x squared plus 2x. Whenever I see an x, I'm going to put a 3x squared plus 2x in its place. 4. There's an x. I'm going to put a 3x squared plus 2x in its place. And now I could distribute the 4 if you wanted to. You'd have 12x squared plus 8x. You could take out a GCF if you wanted to. You could leave it like this. That's fine. We did the algebra. So that tells me that g of f of x is equal to 12x squared plus 8x. And that's the answer. We're doing it algebraically now. All right, let's try to find f of g of x. So we could write it like this. F of g of x. That's a little easier. Let's come down here. G of x is 4x. So let's put that there in place of g of x. So now, anywhere in f, I know what f of x is. It's 3x squared plus 2x. But I want to find f of 4x. So wherever I see an x in f, I'm going to put a 4x in its place. 3 times 4x squared plus 2 times 4x. So that's 3. Got to do exponents first. 4x squared is 16x squared plus 8x, which is 48x squared plus 8x. You could factor out 8x if you wanted to. 8x, it would give you 6x plus 1. So f of g of x, we'll come over here. F of g of x comes out to be 8x times 6x plus 1, or 48x squared plus 8x. That's my answer for f of g. We're literally taking one function and putting it inside the other. Okay, let's try to find h of g of x with these two examples that we have here. All right, so now we're going to look inside the parentheses first. That's g of x. In place of g of x is going 4x plus 3. So that's h of 4x plus 3. Now, wherever I see an x in h, I'm going to replace it with a 4x plus 3. Here we go. 0.5, replace x with 4x plus 3, minus 9. And now we'll try to clean it up. We'll distribute the 1/2. That's 2x minus 1.5, 3 over 2, minus 9. So that's 2x minus 10.5. So that's h of g of x is 2x minus 10.5. There's my answer. Now I want you to take g of x. Take g of x and compose it with itself. Okay, remember, this also could be written like this, just that we understand that both notations mean the same thing. Okay, so g of x is 4x plus 3. That's what's inside the parentheses here, so I'm starting there. So that's g of 4x plus 3. Okay, so now let me come over here and I'll write the original g of x up top. And I want to find g of 4x plus 3. So wherever I see an x in g, I'm going to replace it with a 4x plus 3. Everything else gets rewritten. 4 times, there's an x. I put a 4x plus 3 in its place, plus 3. Distribute the 4. 16x plus 12 plus 3. That's 16x plus 15. So g of x is 16x plus 15. And that's my answer. Okay, that's how we're doing this algebraically. All right, we're doing it literally with variables. Okay, same idea. Find g of f of x. So that's g of f of x. F of x is x squared, the inside. So I want to find g of x of that. So g of x would be square root of x squared plus 4. So to find g of x squared, I'm going to replace all the x's with x squareds. So there's an x. I'm going to replace it with x squared, and then squared is part of g of x plus 4. So g of x squared is the square root of x to the fourth plus 4. There's my answer. The square root of x to the fourth plus 4. Okay, that's how we're doing this, all right? Okay, so now let's talk about domain of composite functions, which is a little bit confusing. So we'll talk about how it works. We're actually going to do it here with some numbers first, so to kind of get you an idea, and then we're going to go ahead and show it to you algebraically. So suppose I have f of x is equal to 1 over x, and g of x is x minus 1. Let's find these 4 values. You should be able to do this pretty easy now, hopefully. We're going to do the inside function first, g of 3. That's 3 minus 1, so that's 2. And then f of 2 is 1/2. So this answer is 1/2. F of g of what? So g of 1 would be 1 minus 1. It's 0. F of 0 is 1 over 0. Oh, we can't do that. That's undefined. So f of g of 1 is undefined. I don't get that answer at all. Can't have 0 in the denominator. So g of f of 2, let's try that. G of f of 2 is 1 over 2. And then g of 1/2 is 1/2 minus 1, negative 1/2. So g of f of 2 is negative 1/2. G of f of 0. So if I try to find f of 0, I get 1 over 0. I can't do anything with that. This is undefined. I didn't even get to reach g of x. So this answer is undefined. Okay, I can't have 0 in the denominator. All right, so you can look and see some of these values or these expressions give us actual numeric answers. Other problems give us things that are undefined. What we're worried about here are the ones that give us things like undefined, okay? Because we're talking about domain, we want to know what works, and usually that consists of us eliminating things that don't work, all right? But notice what's going on here, especially with this letter D, g of f of 0. I took 0 and tried to plug it into f, and it didn't work. It gave me something that was undefined, so I never made it to step 2. I never was able to figure out g of whatever that value was, whatever this value is, because I couldn't find that value to begin with. Okay, that's going to play an important role in our domain. What happens if the inside function, the value doesn't work in the domain of the inside function? Okay, so here we go. The domain of a composite function, f of g of x, is given as the intersection of the domain of f of g of x and the domain of the inner function g of x. So we just saw this a moment ago. To find the domain of a composite function, you actually need 2 different domains. You need to make sure that the value can be plugged into the inside function first, just like we did on the previous slide with g of 0. Okay? Remember, f of 0 we couldn't find, so we never made it to step 2. So the domain of the inside function is just as important. If you can't take the number and plug it into the inside function, you'll never make it to the outside function. So the domain of the entire f of g of x and the domain of the inner function, it must work, the values must work in both of them for it to be a member of the domain of the composite function. So I'm going to show you what I mean here. So let's find f of g of x in its domain. So f of g of x. So g of x is 3 over x minus 5. All right, so let's do this first. 3 over x minus 5. And then I want to find f of that. So f of it is 1 over x. So wherever I see an x in f, let's write it over here. So wherever I see an x in f, I'm going to replace that with a 3 over x minus 5. So I have 1 over 3 over x minus 5. Now, what do I do with this? Well, this is something divided by another fraction. Something divided by something. So that's 1 divided by 3 over x minus 5, which I can put a 1 underneath here, 1 over 1 times x minus 5 over 3. So that's going to be x minus 5 over 3. So f of g of x is x minus 5 over 3. Now, to find the domain of this, I need to know the domain of g of x. That was the inside function. So to find the domain of g, let's go to g of x. Here it is, 3 over x minus 5. We know the denominator can't be 0. So then x can't be 5. So for the domain for g, we know x can't be 5. We'll write our answer in interval notation in a minute. We're just going to try to figure out what doesn't work first. And then for f of g of x, the denominator can't be 0. Well, 3, that's never 0. So there's no value of x that'll make that work. So the domain for f of g is everything. Anything can be plugged in for x because x is only in the numerator. So the domain of the composite, the final domain of the composite, is the combination of the two. Negative infinity to infinity for f of g, but x can't be 5 for g, meaning that if you made x 5 and tried to plug it in, you never would get to step 2. So the domain of f of g means x can't be 5. So we write negative infinity to 5 in the union with 5 to infinity. And that's the correct domain. Okay? All right, let's try another one. We're going to try to go backward here. 1 over x and 3 over x minus 5. So 1 over x and 3 over x minus 5. Now, I want to find g of f of x and its domain. Okay, so f of x is going in first. That's the inside. 1 over x. That's g of 1 over x. So now we have g of x, which is equal to 3 over x minus 5. And we want to put 1 over x in wherever we see an x. So that's 3 over 1 over x minus 5. Now, what do we do with this mess? Well, on the bottom, there's two fractions that we can combine by subtraction. We need a common denominator, though. So let's do that first. Put a 1 underneath there. Common denominator is x. So the first term doesn't really need anything. You could put a 1 there if it helps. The second term needs an x. Multiply top and bottom by x. So that would give us 3 over, the denominator is going to be an x, 1 minus 5x. Okay, now we got one fraction underneath. And then we have 3 over that. So we can do this 5th grade style. 3 divided by 1 minus 5x over x. Put a 1 underneath. That's 3 over 1 times x over 1 minus 5x. So that's going to be 3x over 1 minus 5x. That's my answer. Over 1 minus 5x. So g of f of x is 3x over 1 minus 5x. Now, I want to find the domain. To find the domain, I need to know the domain of the inner function first. The inner function is 1 over x. So x can't be 0. I can't have 0 on the denominator. So for f, x can't be 0. For g of f of x, that's what we just found. Again, the denominator can't be 0. So if I solve this for x, x can't be 1 over 5. So now, to find the domain of g of f of x, I have to throw out the 0 and the 1/5. It can't be 0 because if it were 0, you never would have made it to step 2 to plug into g. And 1/5 doesn't work because the answer that we get, 1/5 doesn't work. Can't have 0 in the denominator. So my domain will be negative infinity to 0 in the union with 0 to 1/5 in the union with 1/5 to infinity. Again, you don't see that. Make your little number line here. We got 0, we got 1/5, no 0, no 1/5. There's 1, 2, 3 regions to write down for the domain. This is the correct domain. That's the correct g of f of x. And that's how we do this. Okay? And as always, thanks for clicking.